Last time we were finishing up section 3.4. We were taking a look at, well, the point where we were looking at mental math toward the end. And we were about to get to the point where we were going to do estimation, and that's where we're going to pick up today, is with estimation on problem or example 23. Looks like this. Okay, so there's several ways to estimate. One of them that you're very familiar with is called rounding, and we will get to that one. But that's not the be-all and end-all for estimating for a sum, okay? So I want to present to you first one that's called Frontend Estimation with adjustment, all right? So what we're going to do is we're going to write down our facts in a vertical format, just like we have been doing. But what we're going to do is we're only going to write the first digit. Everything else becomes zeros. Okay, so that's the front-end estimation part. You use the front or first digit, and everything else is zeros. So 332 becomes 300, 462 becomes 400, 225 becomes 200. Okay, so that's not rounding, right? Because, for example, the 462 would not have rounded to 400, correct? It would have rounded to 500. So we're not rounding, we're just chopping off the end of the numbers and replacing it all with zeros. All right, so what is 300 plus 400 plus 200? 900, right. Okay, so this is the front end part right here. The adjustment part means taking the pieces that are left over, the parts that we turned into zeros, and looking for approximations with the compatible numbers. So 32, 62, and 25. So if I were to take a couple of these and combine them together, do I have almost compatible numbers here within any of this set? What two numbers look like they're almost compatible from what we did last time? The 32 and the 62, right? It's not perfectly 100, but it's awfully close. Agreed? So these two right here, we're going to replace with 100. This is the adjustment part. And then the 25 can stay 25, so I have 125. That's the adjustment. And if I take these two and I add them together, that will be front-end estimation with adjustment for a total of what? Yeah, 1,025. Yes, ma'am. Well, the two twos didn't go away any more than the 30 and the 60 became 90, because, I mean, we're just estimating. It's an estimation, remember? This isn't an exact answer. Estimation. So 32 and 62, like, actually that's really 94, agreed? Yeah, and we're saying that it's about 100. That's what we're doing. Okay? Any other questions on this one?
So if you get, like, say that 62 was 15 or something, like, what would you do?
We would combine maybe the 15 and the 25 to be 50 kind of thing.
Okay.
We might combine other values together. They don't necessarily have to go up to 100, but oftentimes they do.
Okay.
Yeah. Okay, let's do another one. This is grouping to nice numbers. So we kind of did this a little bit with my adjustment over here, as we said, oh, the 32 and the 62 are kind of nice. They're almost compatible. Same idea over here. So we're looking for numbers that we can group together, and again, that would be almost compatible. So are there any pairs of numbers here that seem like that if we put them together first, that they'd be almost 100? 35 and 55. That's pretty close, right? Okay, so that's about 100. Any others? 42 and 64, it's about 100. And then I've got the 71 left over right here. So this is about 270. Now, just to give you some perspective, that's not the answer I actually have on my paper. I have 255. That's the estimation I came up with because I grouped mine differently. So when I did my grouping, and maybe this is what you wanted to tell me as well, I actually grouped the 35 and the 71. Those are the numbers I grouped together. And so I had a 55 left over, so my estimation was about 255. Okay.
Can you do the approximation?
Yes, absolutely. It's a good idea to do so, in fact. Yeah. Thanks, Kayla. All right, clustering is another one that's very interesting. Clustering doesn't work for everything. I mean, the nice numbers over here don't work for everything, right? So like the ones you were asking me about, I mean, there aren't always going to be numbers that pair up perfectly. So that might not always be a good strategy. Clustering is much like that as well. Clustering works when all the numbers are kind of close to the same number to begin with. So if you look at these numbers, 442, 538, 457, 554, and 497, what are they all pretty close to? About 500, right? Does everybody see that okay? I mean, these are all pretty close to 500, each of them. Some of them closer than others, but they're about 500. So this is approximately equal to 500 times 5, because there's 5 numbers. What is 500 times 5? 2,500. Okay, so, right, that's pretty specific. Numbers don't always do that, but there are lists of numbers that will sometimes. Now, I mentioned this one before. Now we're going to actually do the example with it, rounding. When you're not told how to round, you get to pick. So we're going to do this one in a couple of ways. So we're going to do rounding to the thousands. And we're going to do rounding to the hundreds. There's not a right or a wrong because it doesn't tell you what to do, which means that you can pick one. I'm just saying that we're going to do it twice, okay? So when you're doing your homework, you're not going to have to do this problem twice. You just pick which one you want to do and go with it. Rounding to the thousands is the easiest because you're going to have the most zeros going on. So remember, when you're rounding, what you're doing is you're taking whatever the places you're rounding to, in this case, thousands, and I want the number to either stay, the first one to stay a 4, or it will become a 5. Those are my only two options. So this number becomes either 4,000 if I round down or 5,000 if I round up. That's what I do, all right? It's one or the other. It doesn't become 3 in any way, shape, or form. Occasionally I have people who think that rounding down means I round down even further than the 4. No. All right, and the way that we determine it is that we look at our second digit after that, or the digit after that, the second digit of this one, the 7. 5 and up, we round up. 4 and down, we round down. So will this be 4,000 or will it be 5,000? It'll be 5,000 because it's a 7, which means it rounds up. On the next one, I have a 1 here. So will this be 3,000 or will this be 4,000? 3,000. I will round down on this one. And then 5,000 plus 3,000 is 8,000. Now we'll do the problem again. Oops, I meant to grab the eraser. We'll do the problem again with the hundreds place. So the hundreds place will be our benchmark, the 7 and the 1. So this one will either stay 4,700 or it will go up to 4,800. This one will stay 3,100, that's down, or it'll go up to 3,200. Those are our choices. So on the first one, the 8 is what determines it. So will this go up to 48 or will it go down to 47? It'll go up to 48. On the second one over here, I've got a 4. So this will this go down to 31 or up to 32? It'll go down to 31. And if I add 4,800 and 3,100, what do I have? 7,900. Now that one actually ends up being very close to the 8,000 that the other version was. That doesn't always happen depending on how the rounding works, whether we round ups or round downs at different places. But on this one ends up being very close. One more example of estimation, and this is using the range. The word range is used in a variety of mathematical contexts. Not all of them mean exactly the same thing. You've probably heard range used for like domain and range, X's and Y's for graphing. You may have used it if you've done a statistics class when you're thinking about the range in a statistics class. This has a little bit of that feel to it. So the way that we use range is very much like I was telling you what the rounding up value here is and the rounding down value is. That's what we're going to do for doing range. So for instance, if I took the 370 and I rounded down, I'd get 300. If I took 370 and rounded up, I'd get 400. That's the range of rounded values I could get, somewhere between 300 to 400. And then if I did the same thing with 600, what do I get the 647 if I round down? 600, and if I round up? 700. And what we do is we add together the low estimates and we add together the high estimates. So if I add together my low estimates, what's 300 plus 600? 900. And what about my high estimates, 4 and 7? 1100. So my range gives me a range of values. It's telling me that the actual answer is somewhere between 900 and 1100. Okay, so I don't get a single value as an estimate. I get a range of values. Make sense? All right.